Very well. The first thing is going to be to remove all the components of the voltage adapter. The next thing is going to be to solder two cables to the positive and negative of the battery. Very well, we already have the positive and the negative. The battery is ready and glued. Now we are going to place the module. This one here. We are going to glue it on the battery. We are going to put a little glue and put it there. We are going to place the positive to the positive input that we have here, and the negative to the negative input. We are going to solder it that way. Now, as I mentioned, the negative to the negative, and the positive to the positive. But first, we are going to add two more cables, one negative, and one positive. We are going to solder this to our charging module, to the negative, and to the positive. Well, we have already soldered the charger, the XL6009 module, and our battery. With the three components together now, we are going to see the voltage that we can obtain using the XL6009 module. We are going to regulate it until we have the voltage that we need to measure the components. But first we are going to solder a 4.7 kilo ohm resistor of 1/4 of a watt, or half a watt. We are going to solder it exactly on the positive output. We are going to solder a white wire on the negative. Well, then we have a positive output to the resistor, and the negative output to our cable. Let's move on to do the testing or calibration. And only then we are going to make the connections to the output points. Well guys, now we are going to raise the voltage that the module is giving us, which in this case is 15 volts from 4.2 volts of the battery. So we are going to increase it little by little. Okay, we'll leave it at 40 volts, which is enough for most of the components. Now don't forget that we have the positive output of the module to the resistor. The resistor end is going to be our positive for the components. The negative end of the module is going to be the negative for the components. You can change the resistor for a half watt one if you have one, and if space allows. Okay, now we move on to making the connections to the terminals or pins of the voltage adapter. And to the connectors for the tips of the multimeter. Very well, we are going to solder two cables to the output of the resistor. We do the same with the negative. Now we take a cable from each one. We have positive, and we have negative. We are going to solder this to the connectors. We are going to connect the negative to the black and the positive to the red. We already have positive, and we already have negative. Now we have to do the same with these ends. Be careful with the pins, don't make them make contact with each other, since they could cause a short circuit. And if you can, disconnect the positive from the battery while you do the other soldering. Now you have to solder the cables exactly on the pins of the voltage adapter. You have to solder them there. The negative has to go on this side, and the positive on this side so that it matches the pins of the multimeter. Very well. We now have the positive and negative cables soldered to the adapter pins. Now for precaution, we are going to place a switch from the positive input to one of the switch pins. And we are going to place the switch output to the positive of the battery to cut off the power. Very well. With this, we will be able to turn it on and off. Just in case we left it off. Let's move on to the assembly in our cabinet without forgetting that we have to make the holes for the charger, for the switch, and for the connectors. We have to make the holes so they can fit. Very well, we will make the holes. Well, now we move on to assemble our device. We are going to place the switch first. Now we are going to place the contacts. There we would have the contacts for the tips of the multimeter. Now we are going to place our charger or module to charge the battery. We are going to place it, and we are going to stick it with silicone or with enough glue. Okay, we wait for the glue to dry, and then we cover our measuring device. Okay, now that everything is in place, we can test our device with the multimeter. Okay, guys, now we're going to test our measuring instrument. We're going to connect it to our multimeter. We have to work with direct current voltage. The range can be 200 volts, or the range that allows measuring 40 volts. We put this directly on our multimeter. Remember that this side is positive, and this side is negative. We turn on the switch. We have 40 volts. Now we are going to put the tester tips. Well, now to test our device, we are going to use some components that are complicated to measure, as is the case with Zener diodes. Here I have a Zener diode which we are going to measure. Remember that Zener diodes are measured in reverse. The negative to the anode, and the cathode to positive. There you can see that it would be a 15-volt Zener. We invert it, and it shows 0.6 volts. Now if I short circuit, it shows 0. Don't worry, you will short circuit. Remember that we have a 4.7 kilo ohm resistor of 1/4 of a watt. And if possible, change that resistor for a 1/2 watt once so that it can last much longer. Here I have another Zener diode. Anode to negative, cathode to positive. This is a 4.7 volt Zener. Here I have a high brightness LED. We can see that it reads 2.5 volts and it shines quite well. I also have a varistor. This is a 22-volt varistor, and we will see what voltage it works at. 27 volts. This has no polarity, so it doesn't matter if you turn it around. It should measure almost the same. The varistor is in good condition. We can also measure the diax. Here I have a DIAC. The DIAC has no polarity, so there is no problem measuring it from one side or the other. We have 23 volts. We put it upside down. It reads the same. The DIAC is fine, just in case it is a DB3. We also have the common LEDs. Negative positive. 1.8 volts. It is in good condition. Now we can also measure the LED light bulbs. These ones here. If it is damaged, you can use this to check up to which part of the LEDs are fine. It is a 5-volt LED. It shows 10 volts, 15 volts, and this one does not work. This LED is damaged. $20 volts, 30 volts, and 36 volts. So with this instrument, with this one here, you can measure components that are very complicated to measure and do the tests. There you can see how the LEDs shine, and you can easily make the repairs more efficiently. This would be the circuit that we are going to put together. Keep in mind that it is for 220 volts. Then I will explain the changes that you are going to make for 120 volts. And then I will explain in detail how the circuit works. The first thing we are going to do is to put together this circuit. So let's move on to the assembly inside this connector. To do this, the first thing we will do is to put together the diode bridge using the 4 diodes. Now we are going to solder the 2 pairs of diodes, the positive to the positive of the other pair, and the negative to the negative of the other pair. Well, here we have our diode bridge, which has to match the diode bridge diagram. So this would be like this. Our bridge would be like this. We have cathode, cathode, anode, anode, cathode, cathode, and cathode, cathode. Well, now let's move on to the next step. Place the 2 resistors right at these points here. Well, let's move on to that. Very well, now we have the resistors soldered. Don't forget that in this case we have a positive output and a negative output. These are the alternating current inputs. Very well, now what is left is to place a 100 kilo ohm resistor between the positive output and the negative output of the rectifier bridge. That is to say that it must be placed right between this point and this point, the 100 kilo ohm resistor. Very well, guys, the 100 kilo ohm resistor is already placed between negative and positive. Now what is left is to place the 20 kilo ohm resistor right on the positive of the diode bridge. The positive of the diode bridge is where the cathodes are connected. Here I have cathode, and here I have cathode. This would be positive. Now where the anodes are, it would be negative. So be careful with that. So we connect the 20 kilo ohm resistor to then move on to the next step. Very well, we have everything soldered, only the cables remain to be soldered, or multimeter test cables to be able to make the measurements. Let's place that and then put everything in the encapsulation. That is, we only have to solder the test leads to the resistor and to negative. We solder them. This would be negative, and this would be positive. We solder the positive cable here and the negative cable here, the cables of the test leads. Now so that the cables don't move, you can put glue. And this way they won't move, and we will avoid any short circuit that may be generated. First, what we're going to do is ignore the 100 kilo ohm resistor. Then we're going to join this point. With this point, we have positive, and we have negative. Now at one point the alternating current signal will have positive at one end and negative at the other end. The positive will be able to pass through D4 to positive, and the negative will be able to pass through D2 to negative, allowing the current to circulate through the diode bridge from the alternating current power supply. So we will have a current flow. What is the value of the current? Well, it would be equal to the voltage on the resistor. In this situation, we have 220 volts. The 40 kilo ohm resistor would be the sum of 20 plus 20, which would be the ones that limit the current. Therefore, we would have a maximum current of 5.5 milliamps, which you can manipulate without any danger. Now the issue of the power of the resistors. Why do I use a 1 watt resistor and not a quarter watt resistor? Well, it is due to the current and voltage that are being used. Since the power is equal to the current times voltage, where we have 5.5 milliamps times 110 volts, which would be the 220 volts that are divided into the two resistors. 110 here and 110 here give me 220. Therefore, the power of the resistor would be equal to 605 milliwatts, or 0.6 watts. Therefore, yes or yes, I need to use a 1 watt resistor. Now, if you use 120 volts, you can reduce the value of the resistors to 10 kilo ohms. The power can also be reduced. Instead of 1 watt, you can use half a watt. Now, what is the 100 kilo ohm resistor for? Well, when you do not use the 100 kilo ohm resistor, the voltage at the ends can reach up to 310 volts, which is the result of 220 volts by square root of 2. Therefore, when we do not use the 100 kilo ohm resistor, we could reach a maximum value of 310 V. When you use 120 volts, your maximum voltage would be 170 volts. However, when you use the 100 kilo ohm resistor, this voltage is reduced to almost half. In this case, between 140 and 150 volts approximately. It's up to you whether to put it or not. In the case of 120 volts, it would give me 170 volts as maximum voltage. I don't see any need to put it, but in the case of 220 volts, it would be good to put it so that the voltage is not too high. Lastly, the 20 kilo ohm resistor. The 20 kilo ohm resistor is another protection element. We have a protection, another protection, and this would be a third protection. In passing, the current is reduced a little more. Since the current is going to be reduced because we have 3 resistors in series. Therefore, this current is going to drop to 3.6 milliamps, which would be the result of 220 volts divided by 20 plus 20 plus 20, which would be 60 kilo ohms. It is another element of protection. It is not necessary that it be half or 1 watt since you are going to use it for a few seconds. Well, that concludes the theory. Let's move on to practice. Very well, guys. Before starting the test with our instrument, we are going to check its status. For that, you must go to continuity. And with the tips of the multimeter, check if there is continuity in our instrument. Nothing, everything is fine. Nothing, everything is fine. We test here. Nothing. We invert. Nothing. It means that it is in good condition. Now we can move on to testing the components. For that, we are going to go to direct current voltage, range of 200 volts or greater than this. We use 2 alligator clips. Positive to positive and negative to negative. We connect. We have 144 volts. If you use 220 volts, you will have that voltage. If you use 120, you will have less voltage. You can touch one of the tips. Nothing happens. If you touch both, you will feel a slight tingling. We have a varistor. We are going to test its condition. For the preference test, you should only touch one of the tips. It is 28 volts. It is in good condition. The microwave diode. It is 7 volts. It is in good condition. Zener diode. The Zener diode is measured in reverse. Anode to negative and cathode to positive. It is more than 14 volts, or approximately. Anode to negative and cathode to positive. It is a 4.7 volt Zener. We invert it. 0.6 volts. You can also measure the voltage of the LEDs, but be very careful when measuring it in reverse. Remember that the LEDs can burn with a voltage greater than 50 volts in reverse. This LED is burned. This one is fine. You can also measure the LED bulbs. In that way, this would be the cell phone charger's electronic board. These types of boards work the same way as the boards in switching power supplies. And charger boards usually have a Zener diode like this one here, from 5, 9, or 12 volts. This determines the output voltage of the power supply. However, sometimes chargers, as well as switching power supplies, often have a programmable Zener diode. As is the case with the TL431, this one here. In the case of this power supply, we can see that this would be 431. However, on our cell phone charger, we have it right here. And as you can see, it says 431. That's a programmable Zener diode, which we'll have to replace with a regular Zener diode in order to raise the voltage of our charger. Well, for that, let's look at some theory. Okay, now for some theory. Now on our electronics board, we have the TL431 in SMD format, where pin 1 is the reference, pin 2 is the cathode, and pin 3 is the anode. And the connections would be more or less these, where we have pin 3 of the TL431, or cathode. It's connected to the cathode of the LED of the optocoupler. and the anode is connected to the negative. What the programmable Zener diode does is activate at the voltage that was programmed through this potentiometer, or through this integrated circuit. This means that when the output voltage reaches the programmed voltage, the LED will activate, and then the transistor will activate, causing the rest of the circuit to stop increasing the output voltage. Therefore, that's how the TL431 works. However, what we want is to have a different voltage than the one already programmed. Therefore, what we're going to do is replace this programmable Zener diode with a normal Zener diode. That is, with this Zener diode, whether it's 5, 10, 15, or 30 volts. For this, the connections would be these here. We're going to connect the Zener diode directly, the cathode to the cathode, and the anode to the negative, nothing else. And then verify that at the output we have the voltage indicated by the Zener diode, added to the necessary voltage of the LED. That is, if I input 5 volts plus 1 volt, I'll have 6 volts here. That would be the whole theory. Now let's verify all this in practice. Okay, the first thing we're going to do is remove the TL431. Okay, now we're going to insert a Zener diode. This one here is 4.7 volts. Cathode has to go to cathode. Remember that in the case of the programmable diode, the cathode is pin 2, and the anode is pin 3. Cathode, anode. Very good. Now let's test the output voltage of our charger. It should give us approximately 6 volts. Our multimeter has to be set to DC voltage. Negative to negative. And positive to positive. There we have 6 volts. That means the modification was a success. So, now we're going to modify it so that our charger can deliver 25 or 27 volts. So let's make that modification. Okay, first, we're going to remove the Zener diode. Now we're going to install 2 diodes, one 10 volts and one 15 volts, so that together they give us 25 volts. If you have a 25 volt one, you can put it in, but the voltage must not exceed 25 volts. I'll explain why later. Okay, we're done. We have the 10 volt and 15 volt Zener diodes. We would have a 25 volt output. Now, keep in mind that we'll have a 25 volt output, which means we have to modify a few other things. And I'm referring to the capacitors. Here you can see that we have 2 10-volt capacitors with 470 microfarads. We have to replace these capacitors with one that's higher than 27 volts. The capacitance may be the same or it may be lower. There won't be any problem if the capacitance is lower. For example, in my case, I'm going to use a 35-volt, 100 microfarad capacitor, just one instead of two. The other issue is the Schottky diode on the electronic board. In this case, it's the SR5100, which can operate up to 100 volts at 5 amps. Take into account the maximum voltage at which the diode can operate. If it can't operate above 30 volts, then it needs to be replaced. In my case, it's not necessary. Therefore, I only need to replace the two capacitors. So I can run the tests again later via USB. Okay, now we've modified our charger. Now, let's add a voltmeter. One of these. This has 3 wires, allowing us to power it through an independent power supply. And measure the voltage across the yellow wire, the test voltage. I'll show you the circuit right away, showing how it should be connected to our charger. However, before that, let's remove the USB connector. Okay, the connections for the voltmeter we're using would be these here. Normally, a voltmeter like this has a yellow wire instead of a green one, but I used this green wire. Now, the connections would be as follows. The red wire is positive to the 27 volts supplied by our cell phone charger. The black wire is negative, and the green wire toward the component or load we're going to measure. Between the red wire and the green wire, there will need to be a 4.7 kilo quarter-watt resistor, like this one here. Now, to measure the component or load, we'll have to use the leads of a multimeter you're not using. The black one will go directly to negative, and the red one will have to be connected to the green wire, or to the end of the resistor. Well, those would be the connections. Let's make the connections and then test the equipment. Very good. Now that we've finished making the connections, let's apply glue so the wires don't move. Very good. Once the glue has dried, we can test our modified board. We put it together. Ready. Now we have to plug it into the power outlet. There we can see the voltage. It's 25 volts. And if we touch the leads, 0 volts. Okay, now let's finish putting it together properly so we can test it with the components. Okay, guys, now that we've finished our measuring tool, look how it turned out. It turned out very well. Now let's test it by measuring some components. We have 25 volts. Now for something very important. According to the data sheet, the voltmeter must be powered with a voltage less than 30 volts. That's why we're using 25 volts, not 30 volts, or a higher voltage. 25 volts are enough to measure many components, such as an LED. There we have 1.85 volts, which is fine for an LED. We also have Zener diodes. In the case of Zener diodes, these must be measured in reverse. The cathode is positive, and the anode is negative. That's a 4.7 volt Zener diode. If I measure it forward in reverse, it will measure like a normal diode. We have a 0.7 volt drop. Here I have another Zener diode. Always remember to measure in reverse. Cathode to positive, and anode to negative. This is a 10 volt Zener diode. The other way around is 0.7 volts. Here I have another Zener. It's a 15 volt one. In the same way, you can use the tool to measure the status of the LEDs in the light bulbs when you need to repair them. We have a 5 volt drop from 10 volts, from 15 volts. It doesn't turn on. This LED is burned out. So, this way, you can use the measuring tool. Our tool can deliver more voltage than the multimeter can, which is why it's quite useful. Well, this way I would conclude the video. Now, don't forget that if you like the video, a like helps the channel a lot. See you in the next video. Bye-bye.